Okay. All right, so it says to raise money for charity. It says 0.15 was collected from every ticket sold to a Lions baseball game. If you bought 12 tickets, how much money would go to charity? Well, I think it's kind of a no-brainer. It's going to be 0.15 times 12. What timing? Boy, the phone rings the moment my lesson starts.
Mr. Glazer's classroom student speaking. Yeah.
So one way to do this, and this is the example they show you, and it's kind of cumbersome, which means it's kind of a hassle to do it this way. You could add 0.15 12 times. 0.15, writing all that down, then you add them all up, and so what are you going to get? You're going to get 180 or $1.80 because it's 15 cents. The 0.15 stands for 15 cents. The other way to do it is to multiply it, okay? And they did 12 times 15, and again, you get the same thing, 180. And then in this one, they did 12 times, instead of just 12 times 15, they did 12 times 0.15. Now, what I want to point out to you guys that some of you may have already noticed is that if you look at it in the box in C here, you come up with the same answer, except in the second one, you account for the decimal. And so let me just show you guys something here. Take a look at this. I'm just going to do something like this. X, 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 X. And I'm going to put a decimal right there. And then it's going to be, actually maybe I shouldn't use X because I'm going to put the symbol for multiplication, which is an X. Let's just say, what letter could I use? How about Z? Z, 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 Z. Okay. Times Z. And my answer is Z, Z, Z. Okay? So, where's the decimal go? Where's this decimal go right here?
Before the second class Z?
Yeah, it goes right here. So, how many decimals, if we were to move them all the way to the right, how many times do I count over? 1. So then when I get my answer, I just count back 1. And so look at this, look at the example they gave us here, okay? It was 12 times 0.15. The answer was 180, 180. How many places would I have to move the decimal all the way to the right? To get it all the way to the right, it's just 2 places, 1, 2. So it's 1.8. Let me give you another one. Because I'm seeing some blank looks here. So let's say it was point A times A. And my answer is this. Where does the decimal go? Now, I could replace numbers with the letter A, but this shows the same thing. If you think you know where the decimal goes, raise your hand. B, if you're really sure where it goes, raise your hand. Okay. How many places in is this decimal? It's another way to look at it. 2 places in, right? So, start right here, 2 places in. It's going to go right there. You guys see that now? So I could put numbers up there. It's going to be the same thing. Let me do one more. I want you guys to understand this. This is important. So I'm going to do, how about C, D, E? How about E? E, 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 E. I'm going to put the decimal right here, times E. And my answer is, whoops, low space. Yeah, I'm not going to worry about that right now. E, whoop, come on. E, is it still recording? Yes, E, E, E. I'm gonna have to delete some of my videos here. That's my answer. My question is, where's the decimal go? How many places in is the decimal? 3 places. So I move it what? 3 places. 1, 2, 3. It goes right there. 1, 2, 3. 1, 2, 3. You guys see it?
Yeah.
So the same thing, when we have numbers, it's the same thing. If we were to plug in numbers, that's where the decimal's going to go. What they're pointing out here is 12 times 15 is 180. 12 times 0.15, because they got 15 cents for every ticket sold, is, the answer is 180, but the decimal, it's 2 places in, just move it 2 places in. The decimal's going to be right there. Do you see it? Does that make a lot of sense? So just remember that. Just look, whatever numbers you're multiplying together, see where the decimal is. And you really don't even have to worry about the decimal until you're all done. Okay? Does that make it a little easier, thinking about it that way? I hope it does. I saw some lights go on. That was a good thing. All right, so look, let's look at what we got going here. To convince me, it says here are 2 similar problems. Okay, so they got 33 times 19, and then they have a 0.33 times 19. Okay, so I'm going to write this down here so everybody can see it here. Here's 33 times 19. And the answer is 627. Then they have a 0.33 times 19. The answer is 627. I might have said 37. Okay? So, I'm looking at the second one here. Where's the decimal go? Where's my sticks? They're way over there. All right, for 10 points, Miss Rieger, where's the decimal go? In this one, where's the decimal go? No? Okay. 20 points. Miss Noble, where's the decimal go?
It would be before the 2.
Yeah, before the 2. It's because it's 2 places over, and you count 1, 2 places over, it's going to go right there. You solve it the same way, and you don't have to worry about the decimals till you're all done doing the multiplication. Okay? So I think that was really the most important thing I wanted to point out for this lesson. So let's look at some of these here. What's the difference between multiplying a whole number by a decimal and multiplying 2 whole numbers? Well, you have to worry about the decimal, but you guys don't have to worry about that question. I'm crossing out number 1. Number 2, if a group bought 24 tickets, how much more money would go to charity? I like that one. So this is in reference to the one up above. This is worth a stick. I just highlighted that one. Let me show you. This is what they're talking about right here. This problem that we just were using as an example. That's what they're talking about. In this example, they bought 12 tickets. The question up above, or the question actually down below, is what if they bought, in number 2 there, what if they bought 24 tickets? So I want you guys to answer that one. And then 3 through 8, you guys can do those. Okay? If you want me to do a couple of them, if you get stuck, I mean, come on up and ask me. Let's see here. Yeah, you guys can do all those on page 143. I don't see a problem with these. All right, 21. I'm looking at the next page here. To meet a peak energy demand, the electric power cooperative buys back electricity, generally located, okay? They pay 0.07 per solar powered kilowatt hour. How much money does the school make when it sells back? Okay, so this problem is 0.07 times, looks like 956. That's essentially what the problem is right there. Number 22, the airline that Vince is using, baggage weight 41 pounds. He has 2 green bags, each weighing 18.4 pounds, and 1 blue bag weighing, okay, are his bags within the weight limit? Ooh, I like that one. I'm not gonna explain that one. I just want you guys to read it and think about it and give me the solution to that problem. Okay? So that's worth a stick. 23, Michael keeps track of how much time he uses in his family computer. For 10 weeks, he created the frequency table. In other words, how much time he uses. How many hours did Michael spend on the computer? Yeah, you guys can do that one too. I like that one also. I'm going to highlight that one. Whoops. Need my highlighter here. 23, you can definitely do that one. Okay. Yep, worth a stick also. 24, Sarah's multiplying 2 factors. One is a whole number and the other one has 2 decimal places. She says the product could have 1 decimal place. Is she correct? Give an example and explain your reasoning. Think about that one. 25, Heather clears a rectangular region for her yard. The length is a 1-digit whole number and the width is 5.5 meters. What is the least possible area? The least possible area. In other words, what's the smallest number for a 1-digit whole number? Well, it's 1, so I'll let you go from there. And then, let's see here. Yeah, 26, 27, you guys can do. Okay. All right, I'm going to end this video here before I run out of room because it's telling me I'm running out of room.